Hey, welcome to the next presentation in statistics. I hope you've seen the earlier one on introducing statistics, because we're going to pull it apart now as we go into how do you sample, get data, what is data, what sorts of data are there, or data, or whatever you want to say there. And looking around the screen, if we had these various little groups here, here's a mother with baby puppies there, pretty tired, all those little puppies jumping over her. Here are some dudes, looks like some school students or something. Here's a nice flower, don't know what sort of flower that is. And here's a doctor taking somebody's pulse by the looks of things. What sort of measurements do we make when we have these different groups? So there could be quite different nature to the various measurements we might make. And of course, the measurements are generally called data or data. They are the measurements that we're going to make. And we want to first of all say, come up here, what types of measurement do you end up getting in these different scenarios? We'll come down and let's see if we can find some definitions here about types of measurements or data. Okay, well here's a bit of a summary. This summary comes now from Hayes and Harris publications of maths applications. So types of data. Data are individual observations of a variable, something that is varying. Could be eye colour, could be foot length, or people's heights or weights or stuff. Okay, so we can assign some attribute or quality to it. It doesn't have to be a set of numbers, as often people think data. It can be the number of people who have brown eyes, blue eyes, or green eyes, or something like that. Okay, so data, I want you to start thinking more broadly away from just numbers. Okay, so they are measurements. Data are measurements of a variable. What sort of things vary that we like to measure? Well, I've given you one idea there, eye colour, and that would be an example of this type of variation, a categorical variable. Can you see the word category coming in there? So when people can be put in different categories, not measured with numbers, but put into different categories, we call the information a categorical measurement or categorical data. Fairly straightforward. Hopefully you've seen that before, but if you didn't get it then, you can get it now. And what's the other type, which most people think about when you're measuring a variable and you get data there, and they consist of numbers? Well, that's called quantitative, or it's a quantity, and it's got a number measurement. Okay, so a quantitative variable is one which has a numerical value, a number, and it's called numerical data. All right, so that's what you're used to, I guess. In a minute, I want you to pause the presentation and write down all these definitions. These are our, this is our language, starting to build up our tools for statistics in mathematics there. Okay. What about a quantitative? So you're going to use a number, discrete. That's different from this discrete. Discrete like that, double E in English, means you observe certain forms and protocol. Okay, but discrete here in mathematics over here means separate, distinct numbers, exact number values, often coming from counting. I'll count up how many petals a flower has. So I won't get 1.5 or 2 3/4. I'll get exact number values, all right? Nothing in between, if you like. What's the other type of quantitative or number data, numerical data? It's continuous. Okay, something from measuring, like heights, weights. You can have a height 141.57 centimetres. It doesn't have to be exactly 145 or whatever. Okay, so have you got the idea here? This is usually covered in more junior statistics, but we're starting from the basics and building up with our tools now. So let's go down And oh, hang on, I've gone too far, because I want you to have a look at something here. And I want to do this with you. Here are our groups that we were looking at before. And what I want you to think about is what sort of measurements or what sort of variables, and therefore the sort of data you'd get if you were doing measurements on these groups. Now, I'll give you a hint. Some of them have got more than one answer. Okay, so I want you to pause the presentation a minute and have a look at the puppies here and the mother and say, if you had that group of individuals and you were going to get some data points from that, what sort of variables, what sort of things about them would you be measuring? And therefore, what sort of data over this grouping would you be collecting? And then I want you to go and see if you can list down the same for each of these little pictures here. What is going on there? Okay, so then that'll make a good discussion in class, I think, to have a look at that. So pause the presentation. I'm going to come back with some possibilities, and you might have thought of even more possibilities. So pause it now. Okay, we're back again. Have a look here at the puppies. I don't know, what did you think of? Well, you could have coat colour. Coat colour. That would be a categorical variable. Okay, or eye colour, I suppose. Or what could you measure? The weights of the puppies. That would be continuous. Quantitative continuous data. Okay, get the idea. What about this little group here of students or something? Well, I don't know, the way they've lined up, I reckon it's pretty obvious you could compare their heights. Okay, so that would be quantitative continuous data as well. Okay, or again, you could compare eye colour or something, which would be categorical data. Get the idea. You can come up with other things as well, so brainstorm that with the class. What about this diagram here, or this little picture of, I don't know what sort of flower that is. You might try and find that. Botany is not my strong point. Okay, well you could what, count up all the spikes or something. Count up the number of spikes in each little flower, and that would be what, discrete. It would be a number, but it would be a discrete separate number. You couldn't have 1.5 petals or fronds on there or whatever. Or I suppose you could pull them off and weigh them. Okay, so that would be quantitative continuous data. This would be discrete, quantitative but discrete. It would be a measurement. Okay, so get the idea. What about this over here? Well, it's quite clear that she looks like she's doing pulse rate. Pulse rate is counting. So that's going to be discrete. It's going to come up with a number. So it's going to be, it's not categorical therefore, but it's going to be discrete, separate numbers. Could be 59 beats a minute, 72, whatever. Okay, so that's an idea there. Can you come up with any continuous data or categorical data for this one? I suppose you could, because categorical, she could put him in categories. Low pulse rate for age, average pulse rate. I won't use average because that suggests we're adding numbers up and dividing by how many there are. But let's say the usual for your age group, or high for your age group. That would be categorical. Okay, and that just reminds me, come back over to these dudes over here. We could also measure their heights in a non-numerical way. We could say short, medium or tall. So that would be categorical, using our measurements in a categorical way. So you've got to think about these things and see what you can make of the sorts of measurements that you could be taking there, the sorts of data. Okay, are you ready? Let's go and do something now with all this stuff. So here's our first screen clipping of an example from Hayes Publications. So here's our job. We are to classify these variables as categorical, quantitative discrete or quantitative continuous. The number of heads when 4 coins are tossed. Oh, you can only have whole numbers here. The counting numbers. So it's quantitative because it's got a number or numerical data, and it's discrete because you can't have 1.5 heads. What about the favourite variety of fruit eaten by students in a class? Okay, what is it? Variety of fruit is a category or a group. So it's a categorical variable. There's no numbers involved there. It's not numerical or quantitative. Okay, what about the heights of a group of 16-year-old students? Hey, that's going to end up with a number, and it's going to be continuous, okay, because they won't just be separate. 147 centimetres, 162 whatever, they won't be like that. It's going to be 142.15. You'd be measuring to the nearest centimetre or millimetre or something. So you're going to have numbers in between. Okay. All right. Let's go down and have a look at some more that we can do with this. Here we are. There's our flower back again. All right. So I want you to pause the presentation and have a go at these. This is again from Hayes Publications, 5A. Go through. I'll show you the answers at the end there. It's down to O or P. We'll just go a little bit further. Oops, hang on. We'll just go back up a bit. We don't see the answers. So finish off there, question 1 and 2. And let's have a look at the answers there. So you can always scroll forward to look at the answers. Okay, so there's question 1. I think question 2 will use a discussion. Yeah, and have a look at those and do a class discussion on that. So here's question 1. Okay, let's go on. What else have we got to think about as we do statistical work? Okay, so obviously, from what we said in the introductory presentation, we want to collect information or make measurements of people's opinions, categorical or heights or widths or something, which is numerical or quantitative. Okay, so most important thing when you're gathering information is to ask unbiased questions. If we're trying to get opinions, for example, starting there. I want you to think now of these questions. Are any better than others for finding out the answer to what you want? Okay, which of these questions are biased or unbiased? We might discuss that. So pause the presentation and see what you think. All right, let's come back and have a look. Let's read the first one here. It would be better to spend more money on health, wouldn't it? Oh. That's leading the witness, isn't it? As they say in legal circles, it's leading people to an answer. This might be a bit better. Do you think more money should be spent on health? Or could you think of even a better question, less biased than either of those two? Here, we're doing the same thing again here. Don't you think the voting age should be lowered? It's suggesting or leading people to an answer. This might be better. What do you think the voting age should be? Or can you think of another question that is perhaps less leading than either of those two? So that's important when you're talking to people and gathering information from surveys, that you don't lead them in any way. So you're going to ask unbiased questions. All right, what's another way of getting information from people, for example? You could ask students, what do they think the weighting should be in assessment for each of these written tests, investigations, projects? A mark out of 100 for each one, and get them to fill it in. I think written tests are hard. I'll only ask for 30% counting. Then investigations, I want, or maybe 50% on investigations, and the remaining 20 should be on projects out of 100. Okay, so that adds up to 100. You could ask them that. And then another little tricky thing they often do, come down here, they often ask a check question. What percentage of your overall assessment should be given for your work in written tests? Now that's the same thing said in a different way. And what the surveyor is looking for is it consistent with the answer they gave up here? The proportion of importance or something to those. So it's a check question. Okay, just to see if the people are just putting silly answers down or are actually thinking about it. So it's various ways of asking the same thing. Okay, all right, so think about that if you're designing surveys and things later on. So this is our general mathematical principles, and you might pause the presentation a minute and actually note this down. From a mathematics point of view, you must provide some measurement, either an opinion or a length or a width or something. It can be categorical or quantitative, numerical data. And it just must be framed so that only one type of data response is collected from each question. Okay, so you must come out with a clear-cut category, if you like, or a length or whatever. Don't lead the person to a predetermined answer. The question there must be designed to be unambiguous, so the person understands clearly what is going on. There's no ambiguity, no confusion in the way the question is worded. Okay, are you building up some ideas here? Okay, this is a very useful area of mathematics. Okay, one of the most useful, of course, because people want to know how other people feel or who they're going to vote for, that sort of thing. And statistics can provide lots of interesting information. What about if you were a shoe manufacturer? How many of each size shoe do you want to stock or make? Would you make the same, I'll just get rid of this, would you make the same number of size 12 shoes for men as what you would size 6 or 7 or 8? You could do a statistical survey and estimate in the population how many people are in each different size category. All right, okay, let's go on now and have a look at picking up on what we said in the introductory video. We want to sample. That is, we want to find out a little bit about the whole population. This might not be people. It might be, for example, plants. How many Pinus radiata trees grow over a certain height? And we want to know, in the whole population of such trees, how many are in different categories or sizes. So we're going to go out and sample a whole lot of forests and see if we can get an estimate of what the general population of such trees would be like. So a population is the entire set of things, not necessarily people, about which we want to draw a conclusion. And a sample is, as we said before in the earlier presentation, is a selection from that population. Ideally, it nicely describes it and represents it. It gives you a good mini picture of the overall population. Okay, so you might pause the presentation and write down those definitions. Let's go on now and have a look. Here we are. 3 important things when you go out and try and find information. You don't want bias. Bias sample is one which the data has been unduly influenced by the collection of it, and it doesn't represent the whole population. Oh, what about voting in the next election in a state? Okay, you might go to a shopping centre or all the shopping centres around the state and you take the people's opinion. But hang on, would that be a good sample? Who might be left out of that? Well, maybe country people who don't get into the shopping centre very much, and mainly the people in the shopping centres at that time might have been from the city. How do you make sure you represent the country people as well? Okay, so think about those sorts of things. Now, a random sample, so you don't want bias. A random sample is what we're going to do in this course. There are many versions of a random sample. We're only going to do a simple random sample where all members of the population have an equal chance of being selected. Okay, so that sounds fair. But all we're going to do is make sure they all have an equal chance. So that shopping centre one would not be a good random sample. It doesn't give certain groups who aren't shopping at that time a chance of being in it. For example, a lot of people might be at work. Okay, I'll just get rid of this. Right, a simple random sample is what we're going to talk about in this course. And you have some size is a sample that every set of n members of the population has the same chance of being chosen. Okay, so in other words, if you took one sample or another, they would give the same sort of results. Okay, size n, that every set of 50 people that you took would be representative, or if you like, they have the same chance of being chosen as any other group of n or 50 people. All right, so there are some ideas. Again, pause the presentation and make some notes perhaps there. Let's go on and have a look now at some exercises. Oops, I've given you the answers, so we won't do that. We'll just come down here. So, state the population that the survey is trying to estimate and the sample. So what? A pollster asked 500 people if they approve of Mr. John Howard as Prime Minister of Australia. So what's the sample and what's the population? Go through and see if you can list them down so you're getting the idea. Let's have a look at the answers now. And here we are. All right, so check it off there and see what you think. Let's move on and see if we can build up our skills a bit here. Here we have the next one. In each of the following state the intended population, the sample, and any possible bias the sample might have. We're not doing all the questions from Hayes here because we're only going to work with simple random samples. They talk about other sampling techniques as well. Okay, so read it through, pause the presentation and see if you can state these three things for each of the parts A to D. Right, let's look at the answers now. And here we have them. Okay, so study it carefully. Are you getting the hang of it? How to set up a survey, how to collect data so that we can estimate what's going on in a population and get a good picture of that. Okay, come on down. Let's do the last question in this little set. Question 5 there. This is a production sort of question. Read it through, and it's about quality control. So in other words, it's very important. Statistics is very important in quality control, where people are trying to control the quality of what they do in manufacture on a production line or something like that. And they come out and they test the product regularly. They want to see if that's a good sample of what they're producing, so they can guarantee that the quality is still there. Now have a look at that one and pause it, think about it, and I'll show you the answer now. There we have it. All right, getting the idea. Okay, last little part now in this presentation is to do with random sampling and, if you like, how you do it and some of the terms there. So we've talked about random sampling, and the most important thing when you're doing this in actual practice is make sure the individuals are randomly chosen from the population and you've taken enough individuals to represent the whole population. So this is a very contentious question in statistics. How many people do you have to survey? How many trees do you have to measure to get an idea of the distribution of heights? Okay, so there's two questions here. You must make sure all the people in the population have an equal opportunity of being included. So that is that they're randomly chosen. This is very hard to do. Okay, and even if it is randomly chosen, that doesn't guarantee that all types of individuals will be included. This is a simple random sample we're talking about now. There are other samples, stratified samples, where you make sure the various groups within the population are represented in the same proportions. That's harder to do. But a simple random sample does have the little bit of a restriction here that, or even though you have tried to make it possible for all members of the population to be represented, there's no guarantee that they were, And there's no guarantee that they're represented in the same proportions as they are in the actual population you're trying to represent or estimate. Okay, so think about that. Let's go down and have a look at this sample size thing. How many do you pick? The size of a sample. Now, the mathematics behind this is beyond this course, certainly, but here are some little rules, if you like. For an extremely large population, or if the population size is unknown, how many do you go out and measure? How many trees do you measure to get an idea of the heights of Pinus radiata trees? Well, here's a little rule. It's approximately, there's a sign, 9,600 divided by r squared. And that's the error that you want. In other words, you want to be within 5% of the actual height, for the average height or something, of trees. How many do you measure? Well, if you want to be within 5%, you'll divide by that number there, the r squared. Okay. If you know the size of the population, then the number you go out and sample is approximately 9,600 times n over 9,600 plus n r squared. There's the error, margin of error that you're prepared to have, and that's how it affects the sample size. So in other words, it will depend on how accurate you want this. If you want it very, very accurately, you will actually have to find or sample more members of the population. Let's see it in action now, and this is a fairly simple rule to apply. So let's see this first one. So examine the effect of a new diabetes drug. A sample has to be taken, and we want to make a large sample. Take a large sample so you'll be very confident that the sample accurately reflects the population. So it's plus or minus 2%. Okay, so what's the sample size? We don't know the whole sample, so it's 9,600 over r squared, which here comes to 9,600 over the percentage is 2, it's 2,400. Okay. If you were prepared to have less accuracy, that is within 10%, you'd be dividing by 10 squared, so you wouldn't have to talk to so many people. But then your estimated usage here, or the effect, would not be as good. It would be only within 10%. Okay, so to be very confident that's within 2% either way, we need to actually take 2,400 people have to be taken there. All right, let's have a look at you having a go in a minute, and let's look at this one. A reporter for the Western Suburbs was seeking answers to the following question. Do you want more money spent on roads? That's not too bad. There's not too much bias there. How could, yes or no, how could he investigate this statistically if there are 87,694 voters and he wishes to be confident within plus or minus 1.5%? Okay, you can't actually go and do everybody on the roll because it's going to take too long and be too expensive. So random sample could be used. Okay, so that means he's got to go somewhere in those suburbs so that everybody has an equal opportunity of being included. And then he's got to pick a pretty big sample, doesn't he? Because the rule here, we know the population is this up here. So coming down here, the formula is 9,600 n over 9,600 plus nr squared. So n here, the total number in the population is 87,694. So we put it in two places in where the n occurs in the formula, and then the percentage error in there. So he's got to actually talk to 4,069, about 4,070, let's say, rounding it off. Can you see the idea? You have two problems. How you're going to sample so you represent everybody. You're going to try to give a simple random sample that's equal opportunity for everyone to be included. Equal opportunity. So you're going to have to think about how you select those voters. What is a way, perhaps? There's some questions coming up about random sampling. You could go to every other house. 87,694. You only want 4,000. We keep getting that. I have to get rid of that. then you want 4,000 out of 87,000. What? That's about 1 in every 20. Oh no, go down up and down every street and take the 20th one. Would that be random enough, do you think? You'd want to go to all the streets perhaps, not just one area. So you've got to get this equal opportunity thing going, and then your N must be big enough to represent the big N, the total people in that population. All right, you're ready to go? Let's try and see if you can do something like that now. Okay, so here are the first few questions. Question 1 to 3. I think there are 9 questions here from Hayes. So I want you to pause the presentation and have a go, and you can scroll forward if you like and look at the answers as you do them. There's question 1 to 3. 4, 5, 6 and 7. And we'll just come down here to 8 and 9. And then I'll give you the answers now. Check them off now. Here they go. All right. So I think you should be pretty well geared up to be able to do your own sampling stuff, and to also be critical and check out surveys that you read. You know what to ask now. How many were asked? Where did they go to gather the information? All that sort of stuff. All right. Well, that's all for this presentation now. I hope you're getting the hang of it. You might go back to the original one, the introductory one, to get your head around where we're trying to go. But other than that, it's cheers for now. I'll see you in the next presentation.